Hello students, in this video we will plot the graph between channel capacity and the transition probability for binary symmetric channel. So first we will see the definition of channel capacity. So there are two definitions for the channel capacity. First one is it is maximum possible bit rate a channel can support without any error. That means we can say how many bits it can transmit or transmit without any error. So that is channel capacity. Second definition is maximum mutual information in any single use of the channel where maximization is over all possible input probability distribution. So this definition we have already seen in the previous video. So I think one video we have done on this definition. So channel capacity is nothing but a mutual information also. We can say mutual information is how mutual information between x and y is. That means how much information we get about x when we receive y. So that is mutual information between x and y. So these are the definitions for the channel capacity. So today's topic is to draw the plot between capacity and the transition probability. So first we will see the binary symmetric channel. So this is binary symmetric channel. These transition probabilities are same, that is P. That's why it is called symmetric. Binary because two inputs 0 and 1. Symmetric because probability of getting y1, that means incorrect reception when x0 is sent, is P, and probability of y0 getting y0 when x1 is transmitted is also P. That's why it is symmetric. And probability of correct reception, probability of y0 given x0 is 1 minus P, and probability of y1 given x1 is also 1 minus P. So this was already, we have seen this part also. So we have, in the previous video we have seen the formula for the capacity. So 1 plus P log to 1 P, P log 2 P plus 1 minus P log to 1 minus P. So this P is this one. So this we have derived in the previous video. So we have to draw the plot between this P and capacity C. So if P equal to 0, that means this P equal to 0, that means error is equal to 0, we can say. This probability, that means probability of getting incorrect reception is 0. You will not get y0 if you have transmitted x1. That means you will get only y0 when x0 is transmitted, and you will get y1 when x1 is transmitted. That means if you have sent 0, you will get 0 only. If you have sent 1, you will get 1 only. There is no case that if you have sent 0 and you are getting 1, or you have sent 1 and you are getting 0. That means error is not there. So P equal to 0. So if P equal to 0, so we will put that value in capacity formula. So C is equal to 1 plus 0 log 2 0. 1 minus P, that is 1 minus 0 log 2 of 1 minus 0 is again 1. So here we have put the value of P, that is equal to 1. That is equal to 0. That is equal to 0. So 0 log 0 multiplied by 0 is 0, and log 2 of 1 minus 0, that is log 2 of 1 is also 0. So in that case capacity we are getting as 1 bits per usage. That means this capacity is maximum, we can say, when P equal to 0. So such a channel is called noiseless channel, because this channel is providing useful information that or you are going to get correct reception. That means if you have received y0, so there are 100% chances that x0 is transmitted, because channel capacity is 1 bits per usage. That means this channel is not making any error. That's why we can say this is a useful channel, because it is providing you information that there is no error, because channel capacity is equal to 1. So here I have written that channel is a noiseless channel because channel capacity is maximum in mutual information when one digit is transmitted. In this case, C equal to 1, that means channel gives useful information between X and Y. Uh, in simple language, I can say that if P equal to 0, that means there is no error. So we already know that P equal to 0, error is not there. In that case, we have calculated C capacity, we are getting as 1 bits per uses. That means this channel is providing information that about X naught when Y naught is received, that there is a correct reception. Next, if P equal to 0.5, that is error is present. So this P equal to 0.5. So again we have put that value 1 plus 0.5 log to 0.5, 1 minus 0.5 log to 1 minus 0.5. So you are getting capacity equal to 0. So if P equal to 0.5, that means capacity you are getting 0. Capacity is again nothing but the mutual information, maximum mutual information. So capacity is equal to 0, that means this channel is not providing any information to you of what was sent. So if you got to Y naught, capacity is 0, that means this channel is not providing you information whether X naught is transmitted or X1 is transmitted. If you received Y1, again it is not providing any information whether X naught is transmitted or X1 is transmitted. So this is a useless channel. That means the in mutual information between output and input is 0. Capacity is 0, that means mutual information between output and input is 0. That means this channel is not giving you any information about what was sent. In the previous case, when P equal to 0, it is this channel is providing information that if you got Y naught, that means 100% you have sent X naught. So next one is so this is a useless channel. So if P equal to 1, then first we have taken P equal to 0, then 0.5, then P equal to 1. So we have put the P equal to 1 and you are getting 1 log to 1, 1 minus 1 log to 0. So you are again getting C equal to 1 bits per usage. So in this case capacity is maximum. If P equal to 1, P equal to 1, that means this part is not there. That means this part is there only. P equal to 1, that means if you have received Y naught, then channel is saying that you have transmitted X1. If you received Y1, channel is saying that you have transmitted X0. That means in this case you can guess what is the input, but in second case you cannot guess what is the input. Suppose you have transmitted 1, you have received a 0, that means channel is if P equal to 1, channel is saying you have transmitted 1. If you have received a 1, channel is saying that you have transmitted 0. That means channel is saying something that there is a total disaster or total distortion. That means if you have received 1, you have sent a 0. If you have received a 0, you have sent a 1. In first case, P equal to 0, channel capacity is maximum, that is 1 bits per usage. That means it is giving you the information. Again channel is equal to mutual information. So it is giving you information that if you have sent 0, if you have received 0, that means you have sent 0. If you have received 1, that means you have sent 1. If P equal to 0.5, in this case capacity is equal to 0. Capacity is nothing but any mutual information between an X and Y. Channel is not giving any information between X and Y. That means if you see the output, you cannot say anything about the input. If P equal to 1, channel is again providing you information that error has occurred. and if you have received 1, you have sent 0. If you have received 0, you have sent 1. So if you plot it, capacity versus P, if P equal to 0, capacity is maximum. Channel is providing you information that correct reception is there. Point 5, channel cannot say anything about input. Again, 1, channel is providing you information because capacity is 1, that there is a error, that there is a 100% error. That means if you have received 1, you have sent 0, and vice versa. So this is it for the channel capacity versus transition probability, that is P. So there is some confusion between mutual information and channel capacity, but you keep in mind that capacity is nothing but the mutual information. You can relate it with that. If the capacity is maximum, that means channel is providing you the information. If capacity is 0, channel is not providing you any information about the input if you have seen the output. So that is it for this video. Thank you.